All right, today we're going to look at some more factoring. In the last lesson video, what we looked at was factoring quadratics, but all the ones we factored, this a value was 1. Today we're going to look at how you do some factoring when that's something other than 1. So in this first problem, you can see our coefficient here is not 1, it's 2. When that happens, then the factoring becomes a little bit more difficult because you have to now consider that when we factor these out, we're not just going to have x and x anymore, because x times x is only x squared, but here we got 2x squared. So that's telling us one of these would also need to have then a 2 on it. So 2x times x would give us that 2x squared. Now our two terms that go in here are still going to multiply to equal this 5 that we have there. However, the two numbers that we pick no longer will necessarily multiply to this 11, because our terms that would multiply to 5 are kind of limited here to just 5 and 1, and of course 5 and 1 don't add up to 11, but that's okay because of the 2 over here. Okay, that means one of these two terms is going to have to get multiplied by 2 in order to equal that 11. So we got to figure out which of these two terms here need to get times by 2, and then that'll add to 11. Well, I think if we multiply the 5 by 2, 5 times 2 is 10, then when we add the 1, that gives us the 11. So when we're factoring this out here, since we want the 5 to get multiplied by 2, and we think about how this is going to get multiplied when we multiply first, outside, inside, last, we want this one to be the 5, because that term is going to get multiplied by the 2x over here. That means this is going to be the 1. So now if we were to multiply this back out, you can see that this will equal the original problem. So if we do that FOIL method, multiplying first, outside, inside, last, we'd get 2x squared multiplying the first terms. We would get plus 10x multiplying the outside, plus 1x multiplying the inside, plus 5 multiplying the last. These two add up to that 11x, and we get the same thing. So the factorization of this one would be what we have right here, of 2x plus 1 times x plus 5. So that would be the factored form of this one. All right, let's try another one. The next one, we got 3x squared minus 4x minus 7. Okay, so factoring this out, we know that, again, it can't just be x and x. One of these needs to have a 3 on it, because we got 3x squared here. Again, we know the two last terms need to multiply to negative 7 here. So what can multiply to negative 7? Something probably here with 7 and 1, with one of them being negative. We got to figure out how can we get one of these to add up to negative 4. But we also have to remember one of these needs to get times by 3. So if we know we got to multiply one of these by 3, if we multiply 7 times 3, that's going to be 21 and 1. That's not going to give us 4. But I think if we times the 1 by 3, then we can get negative 4 out of it, because 1 times 3 is 3. 3 plus negative 7 is the negative 4. So since we want the 1 getting multiplied by 3, the 1 should go here. The minus 7 should go here. Okay, so now looking at this, just to make sure we can multiply the outside and inside terms to make sure those multiply to 3x. These multiply to negative 7x. If we add those up, we do get negative 4x. So that's the factored form right here. All right, let's why don't actually you pause the video and try out number 3 on your own and see if you can get that one. All right, let's see how you did. On this one, you got 4x squared here, so we know it can't be just x and x again. Actually, we got a couple options here. This could be 4 and 1 that multiply to 4. We could also maybe have 2 and 2. Let's try 4 and 1 first and see what we get. Here we know that the two numbers definitely need to multiply to get 2. So 2 and 1 is pretty much our only option here. Can we get 9 by multiplying one of these by 4? Yep, I believe so. If we multiply the 2 by 4, that's 8, plus 1 would be 9. So this should be 2, this should be 1, and that would be the factored form of it. Okay, if you need to, double check it. 8x, 1x, 8 plus 1 is 9. All right, number 4. Okay, this one, pretty much just one choice here. If we got 2x squared, we know this is going to be 2x and x. A little more choices now here with the negative 12, though. With our numbers having to multiply there, this could be something with 3 and 4, 2 and 6, or 1 and 12. We got to think, how can we get 5 out of this by multiplying one of these by 2? And also knowing that one needs to be negative and one needs to be positive. So just kind of looking here, I don't think the last one's going to work. If we multiply this by 2, even with one of them being negative, I don't think there's a way to get 5 out of it. Multiplying the middle one by 2, I don't think multiplying either one of these by 2 would work either, because we're just going to have even numbers. We can't get an odd number out of that. Probably something with 3 and 4 here. So you look at it and try to figure out which one, if we times by 2, could we get 5? So if we times 3 by 2, it'd be 6 and 4. Can we get 5 from 6 and 4? Nope. So I think we need to times the 4 by 2. Then we'd have 8 and 3, and we can get 5 from 8 and 3. So 4 is going to need to go here. 3 is going to need to go here. Now we need to figure out, okay, how do we get the signs to work out here? We want it to be a positive 5. So I think we want that 8, because when we multiply these, we're going to get 8x. We want that to be positive. These are going to multiply to 3x. We want that to be the negative. So negative here. So this is negative, positive here. So this is positive. Now these add up to 8x. So this would be our solution here. So when you got multiple ones, then there's might be a little bit more guessing and checking that goes along with it. All right, number 5. Now again, we want to look at this one. Now here we're starting to get more options, because when we're multiplying, this could be 9 and 1, or 3 and 3 could also multiply to 9. Also here we could have 2 and 2, or 4 and 1. So when you start getting more options, like number 5, there is another way that we can do these two. That's an option for you. It's called factor by grouping. And how the factor by grouping method works is you first want to multiply these two numbers together, 9 and 4, which would in this case be 36. And then what you're going to try to figure out is what two numbers would multiply to 36, and the same two numbers add to equal 15. I think in this case, multiplying to 36 and adding to 15, we could get that by doing, if we got 36 and 15, I think 12 and 3 would work. 12 times 3 is 36, 12 plus 3 is 15. Okay, so if we know it's 12 and 3, what we're going to do is take our 15 here, 15x, and instead of writing it as 15, we're going to write it as 12 and 3. 12 and 3 still add up to 15. And then we're still going to put our 4 here and our 9x squared. So this statement now that we have in this problem is equivalent to what we have here. It just looks different. Okay, we just changed that 15 into a 12 and 3. Now we're going to group together these terms and these terms and figure out what's the greatest common factor. In this first grouping, looks like we can factor out a 3 because 3 goes into 9 and 12. We can also factor out 1x. Okay, and then we're going to write what's left over if we do that. So this would be 3x. If we take 12x divided by 3x, we'd get 4. Okay, looking at our second grouping here, 3x plus 4, it doesn't look like there's any thing that is a greatest common factor other than 1. So if there is nothing, we'll put a 1. And again, since we didn't factor anything out, this will be a 3x plus 4. Notice 3x plus 4, 3x plus 4. So now what we're going to do is factor out that 3x plus 4. So by removing the 3x plus 4, what's going to be left is these two things, which is 3x plus 1. Now this is factored out. This is the factorization of our original problem up here. Just to show you that this is the correct factoring, watch what happens when we multiply this back out. If we FOIL this out, 3x times 3x is going to be 9x squared. 3x times 1 is 3x. Multiplying the inside ones, we get 12x. Multiplying the last ones, we get 4. If we add those middle ones together, we get the same thing we started with. So it is factored correctly. That's called factor by grouping, and it's another option for you if you think it might be a little bit of a harder one. All right, number 6, taking a look at this one. This one might be a good one just to go back to that guessing and checking method. There's only one way to multiply to 5, although there is a couple ways here that we could multiply to the 10x. Could be 10 and 1 or 5 and 2. So let's take a guess at it and see. Let's try 10 and 1 first and see if that will work. So is there a way to get 27 with 5 and 1 if we multiply one of these by 10? If we times this by 10, that'd be 50 and 1. Can't get 27 from 50 and 1. If we multiply the 1 by 10, we'd have 10 and 5. Can't get 27 from that either. So this one must not be 10x and 1x. It must be the 5 and 2. So let's do 5x and 2x. So now if we have 5 and our 1, because we know that's the only way to multiply to 5, how could we get 27 by multiplying one of these by 5 and the other one by 2? Well, let's try doing this way. This would be 25 and 2. Can we get 27 from 25 and 2? Looks like it. Yep, we can. And so since we want the 5 being multiplied by 5, the 5 should go here. The 1 should go here. Because this is positive and this is negative, it looks like both of these need to be negative. Let's just check it up to make sure. So if we multiply these, that's negative 25x. Multiplying these, that's negative 2x. These do add up to negative 27. Looks like this is the correct factor. All right, going to the back of your note sheet. Number 7, why don't you pause and try that one out on your own, see what you get. All right, let's see. Looking at this one, we know that's got to be 1 and 1. This looks like maybe a good one to double or to just do the guess and check again. This could though be 6 and 1 or 2 and 3. Let's try the 6 and 1 first. If we know this has to be 1 and 1, and they have to be positive. Does this work out? We get 6x, 1x. Does that add up to 5? Nope, that adds up to 7. So it must not be the 6 and the 1. Looks like this should be 3x and 2x. Now if we multiply that out, that's 3x, that's 2x, that does add up to 5x. That's the correct one. All right, number 8. Now this one really getting into, again, a lot of options here because you got 3 and 2 or 6 and 1 that could be. This could be a bunch of things like 20 and 1, 10 and 2, 5 and 4. This might be a good one to do that method we did before with the factor by grouping. So let's multiply these two. That's 120. What multiplies to 120 and adds to negative 23? 120 again is kind of a big number. This might be a good one to use a calculator on to try some things. So I don't know, we know 120, 30 goes into that. So 30 times 4, I think, is 120. Could we get, does 30 and 4 add up to negative 23? No, we can't get it. Let's try some other stuff that maybe divides into 120, like 20. 20 and 6. Can we get 23 from 20 and 6? Nope. Let's try 15. 15 and 8. Can we get 23 from 15 and 8? Yeah, we can. So it looks like 15 and 8 are two numbers that multiply to that, and if we make them both negative, they add to negative 23. So what we're going to do for our factor by grouping method then is, instead of writing that negative 23, we're going to write it as negative 15x and negative 8x. Okay, now we're going to group together the first two terms and the last two terms and find the greatest common factor. Okay, so if we group the first two, 3 goes into both of these numbers, and we can take out 1x. So if we do that, that means what's left over here is 2x if we divide the first term by 3x. If we divide 15x by 3x, we get minus 5. Okay, now we're going to do the same thing in the next one. Looks like 4 goes into both those numbers. And since this first term is negative here, let's take out a negative 4 and write what's left over. So if we divide the first one by negative 4, we get 2x. If we divide 20 by negative 4, we get negative 5. Again, notice these are the same. So now we're going to factor out that 2x minus 5. And what's left would be this stuff, 3x minus 4. And there's now the correct factorization of this one. So if you're getting a lot of options and the guess and check maybe looks hard, that's another method, is the factor by grouping method. You might get these coming up on word problems, so let's take a look at one of those. This one says the area of a triangle is 8x squared plus 10x minus 3. Find the dimensions of the rectangle. Well, you guys know from geometry, a rectangle, to find the area, you take the length times the width. So if we can figure out what two things are being multiplied to equal this, in other words, factor it, that would be the length and the width. Okay, so factoring that one, I think we could probably do this one just with the guess and check method. We know 3 here, the only thing to multiply to 3 is 3 and 1. 8 does have some options here. It could be 8 and 1 or 4 and 2. Let's try 8 and 1 first. If we know 3 and 1 are two numbers that are going to be here, can we times one of these by 8 to get 10? If we times this by 8, that'd be 24 and 1. Can't get 10 from 24 and 1. If we times the other one by 8, 3 and 8, can we get 10 from 3 and 8? Nope. So it must not be 8x and that one. It must be 4x and 2x. Now can we place the 3 and 1 in there to get 10? Let's try it out. Let's try 1 and 3 and see if that works. If we multiply these, that's 12. If we multiply this, that's 2. We know it needs to be negative though, so one of them has to be minus and one needs to be plus. I think since we want the bigger one, probably let's put plus and minus here. So then this is going to be negative. That one would be positive. These two do now add to 10. So this would be the way we'd want it factored here. So this would be the length and width here. All right, these last problems, if you like that factor by grouping method, this is just some more practice doing that. If we're doing the factor by grouping again, remember we want to factor or group together the first two and the last two, find the greatest common factor. So in that first one, it looks like it's a 5. And here we can actually pull out 2 x's. So what do we get when we divide now? 5x cubed divided by 5x squared would be 5x. The second one, 5x squared, is actually the same thing we're factoring out, so then we'd have to put a plus 1 here. On the second grouping, looks like we can factor out a 6. And so 30 divided by 6 is 5x. And again, we're factoring out 6, so there'd be a plus 1 there. Now if we factor out this common factor of 5x plus 1, what's left over is 5x squared plus 6. So that's the factored form of this one. All right, next one, let's do the same thing. Again, group together these first two, group together the last two. It looks like 4 would be a number that goes into both of these. Also, it looks like we can pull out 2 x's, so let's pull out a 4x squared here. So what's left over would be 7x plus 4. In the second one, anytime that first term is negative, we for sure want to factor out a negative. Also looks like 3 would be a number here that divides into both of those. The greatest common factor would be 3. So if we divide the first one by negative 3, we'd get 7x. If we divide the second one by negative 3, we'd get positive 4. Again, looking at these parentheses that are the same here. So it's 7x plus 4 is our greatest common factor. What's left over here is 4x squared minus 3. All right. On the next one here, you got some more variables. That's fine to do. We can still do this factor by grouping method by finding greatest common factor here. So on the first one, definitely we can pull out a 4 there. This first one has an x, the second one has an x, so we can take out 1x. The first one has a y, the second one doesn't have a y, so we can't factor out a y, so it would just be 4x. So now I'll write what's left over. If we divide the first one by 4x, we get 4y would be left over. If we divide the second one by 4x, there'd be 1x left. All right, let's do the same thing with the second one. Looks like here 7 is the greatest common factor. So dividing the first one by 7, we'd get 4y. Dividing the second one by 7, there'd be an x left. Factor out the greatest common factor there in parentheses, and what's left over is 4x plus 7. All right, why don't you pause the video and try the last one. See if you can do this one by the factor by grouping method. All right, let's see what you got. If you pull out in this first one, looks like you can take out a 3 and an x squared. Dividing that, then the first one, there'd be a 4u left. In the second one, there would be a v left. In the second one, looks like we can factor out greatest common factor of a 7y. And what's left is 4u plus v. So now, taking out that greatest common factor, this would be the factored form. So factor by grouping is another method. If you like that, you can definitely use it on the problems, or you can use that guess and check method.